we had about a tenfold increase in the amount of virus when it was administered in the morning, which is the onset of the rest period for the mouse, compared to when we administered it in the evening. And we also found that it spread more effectively when it was administered at that time as well.
Was that surprising? Tenfold?
Yes, I was quite surprised that it was that dramatic, because obviously the dosing was the same. And as a control for that, we took mice which have disrupted circadian clocks. We've knocked out a gene called BMAL1, which is a key clock component. And those mice have no circadian rhythms. And what we see with those mice is that when we infect them at different times, it no longer matters what time we infect them. You see high levels of infection across the day at that point.
So then the circadian rhythm then obviously has some influence on the mice's immune system.
It does. There have been quite a lot of recent studies looking at this, looking at how the circadian clock interacts with the immune system, and they do seem to find that at the onset of activity, the immune system is primed for attack, whereas at the onset of rest, it kind of can undergo regeneration and repair at that point. But so we think that's definitely a component of what we're seeing.
Right.
But something that people maybe aren't so aware of is, as well as, is that every single cell in your body has a molecular clock. Every single cell in your body can tell the time using its clock. And viruses need to infect cells in order to replicate. And what we additionally went on to do was just to take cells outside of the body, so there's no immune system at that point, and infect those cells at different times of day. And we see a similar pattern of a variation in how well the virus replicates over the time of day. So it looks to be that every cell in your body could potentially be contributing to this time of day effect we see on infection, not just the immune response to that infection.